Hello guys, welcome back to my channel, Memo African Motives. Still working on revisions and questions from past exam papers. Still having the question paper which was written in February 2022. So this was actually Engineering Science and 3 Forces and February 2022. So if you're new to my channel, please don't freak out. Make sure that you subscribe to my channel and make sure you become part of the family. Become part of the family Memo African Motives, so that you'll be working together as a family. Okay, so you're given the question of forces on fig 1 below shows a system of forces. Okay, so this is a system of forces that we are given. Then we're asked to calculate the sum of the horizontal. Okay, so we need the sum of the horizontal and vertical components. Okay, so how can we calculate this, guys? The first thing, we have to get rid of the angles. So if you are to cross check here, there is this angle, this line here, this line that you're seeing here, it's actually a horizontal line. Here you are given a horizontal line, so which means the forces are going to be taken from this horizontal line here. So there is an angle here of 45 degrees from the horizontal line, which means this one is fine. And this force of 80 kilo, take note, 80 kilonewton, there's an angle in between of 30, and it's facing this one. This is the point. So remember, the forces should be away from the from the point, like this, pointing outside, but this one is pointing in. So you're going to continue with this force. When you're given such type of a question, you just continue that force as it is from that line, as it is, straight as it is. You continue with that force. Now it's outside, so that's your 80 kilonewton now. But what is going to be the angle? Let's consider this, guys. This line here, it's actually a straight line here. From this 8 here, we have taken a straight line, and this one also, we already have this horizontal line. So these are actually vertically opposite angles. So this angle and this angle, they are equal from vertically opposite angles. So if this angle is 30, it means also this angle is 30. So there's an angle of 30 degrees in between the force and the horizontal axis. Okay, so this force now is no longer part of the diagram like this. We are no longer working with this. We are now working with this 80 kilonewton. Okay, this 15 kilonewton is also from the horizontal, and there's an angle here of 60. So this one is fine. We are now left with this 25 kilonewton, which is a vertical component. So that one is actually a vertical force that you are given. Why are we saying that? If we are to cross check here, I want you to cross check something. We are given an angle of 30 here, which means the angle also that is going to remain from a straight line here is 90, because this is 30 plus 30, that is 90, which means this angle is 90. And in between here, we are going to have an angle of 90. Take note, guys, what I'm saying. This is a straight line. Okay, we want to know the angle that is going to affect that, because someone might ask, why are you saying it's a vertical line? This is 90 downwards here. There is 30 plus 60, which is 90. So we are going to remain with 90 degrees here, which this 90 degrees is the same as this 90 degrees. Why? These are actually going to give us this one is 30 plus 45. Okay, then 30 plus 45, out of the 90, this one you're going to have 45. So this one is going to be 60 degrees because of 30 and 9. So if this is 60 degrees, take note, guys, if this is 60 degrees, that means 30, this 30 plus the 60 gives us a 9. So this is actually like a right angle like this. So that means, guys, if this is a right angle, this is a vertical force. We are actually given the force in a vertical way. So there's nothing that you're going to do with this, with one. You're going to work as it is. Okay, so these are the forces that we have. So now let's have the sum of the horizontal. Okay, so let's have our horizontal forces. on 3.11. So the horizontal force is this actually hx, and we know these ones work with cos theta. Okay, so hx is equivalent to, we have this one in this of 80. So this is the horizontal from this point here going to this direction. Take note, guys, from this point here to this direction is positive. So it's 80 cos 30, and it's a positive. So it's 80 cos 30 degrees, which is a positive. And we cannot take this one because it's a vertical. Like I was saying, this is a vertical. So 25 is totally out because it's a vertical. Okay. We move on to this 20 here, this force of 20. So it's 20 cos 45, but it's on the negative side because this is the origin and this side is negative. So it's going, the horizontal will be on this line. This is the horizontal like this, and this is your horizontal here, and this is your vertical. So this is negative horizontal. Okay, so it's going to be negative 20 cos 45, negative 20 cos 45 degrees. Okay, like I was saying, this one is no longer there because it was, remember, it was pointing, the arrow was like this, the arrow was at this point, so it's now this, so it's no longer out. So I'm going to work with this one, and if you are to cross check, it's horizontal, it's on the right hand side, which is a positive. So it's going to be 15 cos 60, which is a positive because this is the horizontal, it's a positive, but the vertical is a negative. Okay, the horizontal is a positive, so it's 15, which means you add 15 cos the angle which is in between, which is 60 degrees, like that. Okay, so that is going to be the total. So make sure that you combine these properly here. So you've got 80, make sure your calculator also is in degrees. 80 cos 30 minus 20 cos 45, this is cos 45, plus 15 cos 60 degrees. Okay, so that's going to be 62.64, 62.64 if you round off properly, 62.64. That is our horizontal component, and it's a positive. So since it is a positive, horizontal can either be this way, so it's either positive or negative. So positive, which means it's actually going to the east. So this is to the east. Okay, then we need the vertical component. This one now, it works with the y-axis, and the vertical component is we are now relating back to the diagram. The first one, the vertical component, this is the vertical component here, which is a positive. It's a positive because of this quadrant here. So it's 80 sine 30, and it's a positive. So you have 80 sine this time, 80 sine 30 degrees. Okay, remember, guys, last time we said this is a vertical. We didn't like involve on the horizontal because it's a straight vertical of what, of 25. So you're going to add, it's facing upwards, so you're going to add 25. Okay, then here, this is your vertical component, is also above the above the horizontal here on top. So it's 25, so it's 20 cos 20 sine 45 plus 20 sine 45. It's a positive, it's facing upwards. Okay, so you're going to add. Then let's cross check this one. This one we said it's out, so we are left with this one, and we said it's a negative. This is below this, like this, guys. This is your reference line like this. Okay, and it's below the line, so it's a negative. The vertical is below, so it's a negative. So it's negative 15. So it's negative 15 sine 60 degrees. Okay, so these are the ones that you're going to combine together to find the vertical component. In this case, we have 8. It's 8, or it's 80. This is 80, not 8. This one, it's 80 sine. Okay, not 8, but 80. Okay, sorry for that mistake. So it's 80 sine 30 degrees. Okay, plus 25 plus 20 sine 45 degrees. Make sure you use your calculator properly. Then minus 15 sine 60 degrees, 15 sine 60 degrees, like that. So you're going to obtain 66,157, something like that, which is 15 something, which is 115. Yeah, 66,15 Newton, and it's a positive, which means the vertical, take note guys, vertical is either is going up or it's going down. So positive, which means it's going up, which is to the north. So this is actually going up, which means it's going to the north. Okay, so that's what we had. We are asked to calculate the sum of the horizontal and the vertical components. Okay, then calculate the magnitude and direction of the resultant force. Calculate the magnitude and direction of the resultant. Okay, so what is going to be the resultant force? Take note guys, this was 3.11 and we need 3.12. If you are to cross-check properly here, the horizontal is to the east, the vertical is to the north, which means these are actually in the first quadrant. They are all positive, so it's actually like this in the first quadrant. So that's where we have your resultant, something like this. Because the vertical is positive, the horizontal is positive, so this is your horizontal 62,64 and the vertical 66, which is to the north facing upwards, is 66,15 like this. So this is the angle and this is the resultant, and this is the direction. Okay, so if you are to cross check the resultant, it's actually going to be taken from your Pythagoras theorem, where your r is equivalent to the square root of the horizontal component squared plus the vertical component squared. Okay, so it's the square root of 62,64 squared plus the vertical, which is 66,15 squared. So this is actually from your Pythagoras theorem. Okay guys, from your trigonometry in mathematics. Yeah, mathematics, trigonometry. I hope we are together in mathematics also, because that's where you obtain these principles of Pythagoras theorem and so forth. So you need also to revise guys, revise a lot. Okay, so you're going to obtain 91,1012, which is 91,10. So it's going to be 91,10 Newton, which is 91,1 Newton. And the theta, so this is actually, because here you need the resultant, it's like the resultant, the magnitude and the direction of the resultant force. So this is the magnitude that you have determined. So the direction now of the resultant now is going to be taken from this is the angle that you're actually referring, but this is, remember, this is east and this is the north pole like this. So it's going to be east going this direction, so it's an east, this east, the angle of theta that you're going to obtain to the north, something like this. So you need to calculate this angle first. So theta from your arctan, because you are given theta. Also, like I was saying guys, these are just mathematical skills. If you are to cross check from your mathematics, you know that if this is theta, this is the opposite and this is the adjacent. So where do you use opposite and adjacent? Is the ratio for tan. Tan uses opposite and adjacent. So theta is equals to arctan opposite, which is the vertical component of 66. So you're actually working with the vertical component, which is 66,15 over the adjacent, which is the horizontal component, which is 62,64 like this. Okay, so that's arctan, that fraction there. Okay, so I'm just going, so guys, next time I'm not going to use the calculator, because I don't know the setup that I did. There's too much light or what's happening, I don't know. So it's 15 like this over 62,64. so this is 62,64. So we are going to obtain 46,56 degrees. Okay, so like I was saying that it's actually, so the direction is actually east, so it's east, the angle of 46,56 degrees to the north. Okay, so this is going to be the direction. So this is the magnitude, so it's a matter of the magnitude, and this is the direction. Okay, so these are actually some of the typical questions that you can have when you are working with these forces. These are actually typical questions that you can find. And another one still on these forces is we are given a figure there, which is on fig 2 below, shows a structure. Calculate the magnitude and nature of the forces in member A, B, and member BC. Actually, guys, there is a way that I normally use to answer these questions, and I don't know if it is going to work for us, but this way it works for me. If you are given, say, that type of a question, what you're going to do is to split this. You split this part here with AB first, okay? At this point here, because this is where we have A, B, and C. So you just work with this point, okay? So this is 3.2 like this. So how do you split this? It's very, very important, okay? So from this point, I'm going to indicate it like this. I'm going to split it like this. This is the 15 kilonewton, which is a support. Then I have A and B, so with an angle of what? Of 45 degrees like that. So I'm just going to indicate like this. This is, okay, this is my A here. This is my B, something like this, and there's an angle of 45 degrees like this. And I have 15 kilonewton. So if you are to cross check, guys, this question actually repeats in the same manner and the same way. So in this case, you're going to like use the upward forces, okay? The sum of the upward forces should be equal to the sum of what? Of the downward forces. So the upward forces, you are referring to this 15, okay? That's your upward force because it's facing upwards. So 15 is equal to the downward force. So the downward force is going to be this one of AB facing downward. So it's AB sine 45 degrees. That's the downward force. So take note, downward, it's like this. That's the downward. Horizontal is this one. That's your horizontal, okay? So it's AB sine theta like this. So to find AB, definitely I'm going to divide by sine 45. So that means AB is equal to 15 over sine 45. So using this way, I'm not going to forget it. So using your calculator, 15 divided by sine 45, guys, is because of my setup. I'm just going to punch out the value. So you're going to obtain something like 21,213 Newton, okay? And this AB is actually a strut, okay? Because this one, they'll be like coming together. So this one is a strut, AB. So actually they ask this question and they repeat this question here and again, okay? So that's your AB. And we need BC. So this is BC here. So BC is on the horizontal. So for B and C, you're going to take this now combined together now like this. It's going to be something like this. Yeah, I'm going to combine like this, okay? So this is my A, my B, and my C. I have my A here, my B, and my C here. If you are to cross check, okay? So that's my A here, my B, and my C. So I'm just going to put my C here and my B, something like this, okay? Then there's an angle of 45 degrees. Is it 45? Guys, the answer is 45 degrees. So now, what am I going to do to find the BC? Because now I want to calculate BC. So BC is like the force which is on the horizontal. This one is on the horizontal. So I'm going to use the sum of the forces to the right and to the left, okay? How can I present this? And let me just write forces right. This one's forces to the right actually, okay, is equal to the forces to the left, the sum. So to the right, which means you are actually referring B and what? This B and C. This is the one that is to the right, okay? So that's BC equal to the left is going to be this AB, but now it's cos 45 because it's supposed to be the other way. So it's AB cos theta, okay? since I have just, okay, I forgot to replace this AB, so I'm just going to use theta. So now let's substitute. BC is equal to AB. AB, remember, we obtained this AB before. This is our AB, which is 21,213. So you're going to obtain the same answer with the other way that you are used to, but this is what I do. Cos theta, which is this cos 45 degrees. Yes. So some, they use tan, they use a ratio which involves tan. It's another way. It's another way of their doing. It's another way of their doing. They obtain the same answer with this one that we are doing here. So you're going to obtain 15 newtons, if I'm not mistaken, something like that. Okay, so that is going to be your BC, and this is a tie actually. Okay, so this is going to give us a tie. So these are actually the stages. These are not newton, these are kilonewtons, guys. We are playing here. These are kilonewtons. Hey. Okay, so these are kilonewtons, which means the first one also we supposed to have kilonewtons here. Kilonewtons. Okay, so guys, make sure that you just correct that. And that's what we had. And like I was saying, that there are so many ways that they can ask this question, and there are so many considerations that you can also answer this question. So as you can see, that's typical questions that you can have. So guys, not to miss these classes, make sure that you subscribe to my channel, Resultant African Motives, and don't freak out, guys. Share, don't forget to like and comment. Let me know the areas that you can actually work on revision, so that as a family we can be able to assist each other. So let me know on the comment section which areas can we focus on or work on. You are the people, and you are the ones with the areas that we can work on. So let us know. So that's it, guys, till we meet again.